Hello, welcome to another video. We're going to do this problem called 605, can place flowers. It's an easy problem LeetCode. Yeah, we're just going to get started. So let's read the problem. So you have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be placed in adjacent plots. Given an integer, that's a good thing to note. So given an integer array, flower bed containing zeros and ones, where 0 means empty and 1 means not empty, and an integer n. Wait, what? What? Well, return true if n new flowers can be planted in the flower bed without violating the no adjacent flower rule, and false otherwise. Okay, cool. So, okay, that's cool. That's cool. Okay, so yeah, that makes sense, I guess. So let me think. Okay, cool. So yeah, let's go ahead and go to our input and output. Input, output. All right, so our input is just basically flower bed, flower bed, which is an int array, and then we're also given n, which is just integer plants to plant, and then to note, um, oh yeah, oops, before we get to notes, I'll get my output. So the output is going to be a bool, and then we can say that true is equal to all plants can be planted, and then false is equal to otherwise. And then we need to note that there is a no adjacent flowers rule. So can't plant 1 1. So can't plant 1 1 0. Basically. Um, so that makes sense. Um, all plants n can be planted. Okay, cool. So, yeah, I think I got the input and output down. Um, then okay, so let's go through some questions, I guess. I have some questions before we go through some examples. So my question is, can input flower bed have adjacent plants by default? And then my question is, what's the min size of flower bed input? And then my other question is, can n be 0? Um, okay, so if we look here, we have the answers. So can input flower bed have adjacent plants by default? There are no adjacent plants by default, so no. What's the min size of flower bed input? That is 1. And can n be 0? Yes, n can be 0. So that's interesting. So now that I know the input and output, took some notes, asked some questions, I think I do understand the problem. So let's go ahead and go through. Before I truly understand, let's go through some examples. So let's say that flower bed is equal to this. So 0 1 0 0 0 1, and then n is equal to 1. Yeah, n is equal to 1. So here, um, I think this is also true. This is true because we're going to be we can't plant here. We can't plant here because there's already planted, and we can't plant here because there's a 1 right here. And but if we go here, we can plant because the to the left is 0, to the left to right is 0. So we can plant here. So true. Okay. So what about if we had this case where it's kind of like the same? It's the same example 2. It's the same one, but n is equal to 2. Well, of course that would be false because um, we can only plant here. So at the end, we're gonna be like, oh, we only planted once. So that means that So that means that we can't plant anymore. So that would turn false. What about if we have example 3, or we have the same thing, I guess, but I guess we have like a 0, 0. Um, I think this is a good edge case too. So we can't plant here. We can't plant here because there's a 1. We can't plant here, even though there's a 0 right here to the right. There is a 1 on the left, so we can't plant there. We can't plant here because both sides have zeros. So it's good. Um, we can't plant here, and I'm guessing that we can plant here because to the left is a 0 and to the right there's nothing. But that still is good for the no adjacent rule. So yeah, this should be true, right? So that's a good thing to note. Okay, so now through input, output, questions, notes, and some examples. So confident that I do understand this problem. So go ahead and kind of get some tools to match on what we can use to solve this problem. So what I'm thinking about right now is just basic if statements, and then we can go through a for loop. By if statements, I kind of want to compare sides. So basically, I minus 1 and I plus 1 is equal to 1 or not, equal to 0, or I don't know, right? So if there's 0, then plant, right? Um, and then for loop, if statements, and then maybe like a counter. I guess like a counter. Do I need a counter? I guess a counter. Um, um, temp var counter to count how many plants placed. And then I guess in the end we can just um just return. But I'm thinking about far ahead. I just need to match the tools. Okay, so that's pretty much it. Okay, there's gonna be a point where we say that we planted it, right? So we planted it, and then there's I guess a 0 or an extra 0 right here. Because so let's say we planted this, right? And then here, we can't here, like, okay, so this is a 0, this is also 0, or like this. There's like a 0 here too. And then even though we planted here, or we said that we can, this will be this will trigger. So I guess we can have like a, I forgot what they call it, like what's it called? Planted planted variable. Basically a bool to flag if planted planted previous. Um, I don't know. So yeah, that these tools make sense to solve this problem. So let's go ahead and kind of plan it out already. So what is this first step that I want to do? Um, is there a first step that I want to do? Of course there is. Um, oh yeah, we want to initialize our temp var. So um, plants planted is equal to 0. Um, and then once we initialize our variable, we can go ahead and start iterating through. So iterates through iterate through plants or flower bed, I should say. So for I in range all the way up to the length of flower bed. We're gonna go through all of flower bed's elements. Um, okay, um, first off, I kind of want to check if the left and right are 0, right? So if if left is equal to left is equal to 0, um, hmm, and or or how do I say this? I want to go to the edge. So if if I if I minus one. Oh yeah, yeah. So basically, I'm trying to get the edge, right? So in this case, let's say like this was a zero, right? I want to plant. We can plant here like it's possible. So I want to say if I is less than if I minus one is less than if I minus one um minus zero. And is it and or or? I don't want to go over bounds. So if I minus one is less than zero, yeah, and yeah, it has to be and this so I don't go out of bounds, right? So first off, and flower bed at I minus one is equal to zero. So if this if it's not planted, then we can say that we can plant it there. So continue, I guess. And then we also have to say so if I plus one is oops if I plus minus one is less than more than equal to zero. Okay. And then if I plus one is less than n, right? Or the length of the flower bed, right? If I plus one is less than the length of the flower bed, yeah, in this case where if we go right, and flower bed at I plus one is equal to zero, then we can continue. So if it's those cases, okay, so then if it is equal to zero, wait, it should be like this. Wait, no. Can it be like that? If I minus one and if it's basically saying, yeah. Um, then we can plant. And we can plant here. So we can say plant. Um, so we can say that planted plus equal to one, right? Um, I think that's fine, right? Check if both sides are okay. So check if both sides are okay. So hmm, I think I like it better if this makes sense. So if they're both equal to zero, then we can plant here. Oh, wait. Um, does my logic make sense? Wait, this wouldn't make sense. Oh, wait, no, my logic is really weird right now. Good thing I'm going through this. Because I'm thinking about, okay, so continue means we just basically go through the for loop. We just go to the next one. So if it is equal to 1, then we just continue. Or we just go to the next one. Um, but if that's not the case, so if we didn't just continue, right? So if this was 0, right? So if this is basically safe. So if I minus 1 is more than equal to 0, right? And flower bed to the left is equal to 1. In this case, um, I minus 1 is not equal to 0. It's negative 1 in this case. Um, so this and is going to cancel. So we won't go through this. Then the right will go through because I plus 1 is 0 plus 1 is 1. And then to the right of it is not equal to 1. So at that point, we're going to say planted plus equal to 1, right? So that makes sense. So this goes through correctly. Um, and then let me think. Okay, let's see. So we planted there. What if we plant here too, right? In this case, oh yeah, we need to have a planted var. So placed. I guess we're gonna name it placed. So placed is equal to false. Place prev. I guess prev planted, right? And then I guess prev planted is equal to true, right? Um, and then I can also say and. I guess I can put it here. So if prev planted. So if prev planted. So if that's true, then we're just going to skip that. Just gonna skip it. So continue, but we also have to say that the previous hasn't been planted yet. So prev planted is equal to false now, and then continue. So this makes sense. And then in the end, we're just going to return if planted is equal to n, and then that should give us a result. Um, so yeah, this makes sense to me. Let's try this example, I guess. Um, no, this should work. This makes sense. So if I plus 1, okay. Okay, cool. So I like how I made this. So this looks good. So I think this plan looks good. So I'm just gonna copy paste it and then we're going to code it up. We're gonna finally implement it. What's the time running? 20 minutes. Okay, it's all right. So let's just go ahead and copy and paste it. All right, I don't need to use test results. All right, so let's go follow our plan, right? So we have to initialize our initial our variables. So planted is equal to 0. and prep planted is equal to false. That's our flag. And then we need to iterate through flower bed. So for I in range, all the way up to the length of flower bed. Um, and then we need to do our cases. So if it is previously planted, right? So if prev planted, then that means that to the left there's already a plant. So we just want to continue and just yeah, we just want to continue. And then if it's the case where if I minus one is in bounds, that's cool. So if it's in bounds and flower bed at I minus one. So basically the left is one. Um, so if the left is one, then we're just going to continue. And then if the right, so check left equal to one. Check right if equal to one. So if I plus one is less than, oops, speed less than equal to. So if I plus one is more than the length of flower bed, and the flower bed at I plus one, so if it's basically in range, is equal to one. If the right is planted, then we're just going to continue. Um, so yeah, previous, I don't think so. Um, and then we can just say that if it doesn't go through all of those, so if it's left is zero and right is zero, then that means that we can plant there. So that means that plant plus equals to one, and then we can say that craft planted is equal to true now, right? And then after the for loop, we're just going to return if planted is equal to n, and it should run it, and it should work. Okay, I failed it. Um, okay, I failed it. Why? Let's go ahead and kind of test this out, right? So why is it not working? So if I plus one, okay, so let's see. So one passes. What is planted in this case? So did I overdo it or underdo it? It's overdone. Interesting. Okay, so what happens here? So one, of course, doesn't go through. Um, because I minus one. Okay, so it's not in bounds. And flower bed to the right is not equal to the left is okay, so it's not so it's not in bounds, so it just skips it. Right, so we can't check, so we just continue. Um and so then we go to wait, okay. So it goes through here. Um oh, I'm stupid. Or or How could I forget this? So if this could be a solve. So if current is equal to 1, then just continue, right? I should solve it. Okay. 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 Yeah, I can't believe I forgot that. I forgot the base case. So submit, please. Okay, so std out true, output true, expected false. Okay, so what happens here? So when you do this, when you do this, I don't know if I do need to do that. I don't think I need to do this. What's wrong with my logic? Okay, so the only there's nothing that um there's nothing that I could plant here. Okay, so this should be okay, so 1. Okay, so continue. So then 0. I checks left, it should be continue. Because if it's equal to 1, then continue. So then we get to 0. This 0 right here. So this 0, we say that we can plant here because left and right is equal to left and right is not equal. Okay, so planet plus 1, so prev equals true. Okay, and then here, we know prev planet is equal to true, so then we should continue there. Huh. Okay. Where do we say that? So print. Right. At 2 and 4. At 2 and 4. So 0, 1, 2. Okay. 3, 4. Why 4? 4. Okay, so planted. Prev. Prev is now false. Okay, so I'm gonna continue. Check left. 0. I plus 1 more than. Why does it 0, 1, 2, 3, 4? Okay, so why does it ignores I plus 1 is equal to 1? I can do this. I don't think so. If I plus 1 is more than, oh, wait, no, less than, right? And this is more than equal. Wait, what is my, okay, it's just a syntax issue. Okay, yeah, I was, okay, cool. So this should work. Oh my God. So it runs at 0, which is cool. And then at 4, 0, 1, 2, 3, 4. 0. Oh, I think my logic and return value is, so I guess I can say, this logic kind of sucks. Um, um, so I guess I can also say, like, if we already reached the max, so if planted, so planted is more than equal to n, we can just break. Okay, this is really slow. What do people do? Hmm. I mean, this case kind of sucks. I mean, I can just return in the end, like, planted more than equal to. That could also work too. Yeah. So instead of just checking every time, right? Just go through all of it. Um, yeah. So that works too. Um, yeah, okay, this is awesome. All right, so that was pretty good. Um, I had a syntax issue, and good thing I've reviewed on the edge cases of lists because I know that's it's going to happen a lot. I minus one to kind of check. So if I minus one is more than equal to 0, then that's fine. And then if we know that's fine, then we can access I minus one and so on. Okay, cool. So that's awesome. Uh, runtime. This is O of n. Um, with O of one space. So yeah.